All right, sometimes banks and entities allow you to compound your interest more than once a year, more than annually. So sometimes you can get it once a year, twice a year, 12 times a year, however many. So this is a slightly different formula. They don't just increase the number of times they add it to you, you know, a little bit more fun to be had here. So we have the number of times per year is your N. So this N is here, and you divide the rate by it. So you're actually splitting up the rate into that many times a year. But then to compensate for that, you're also raising it to that rate's power. T is still the number of years, excuse me. P is still the principal, and this is still your function in terms of time. So what you just have to get used to here, I love it when it does that, is how many times a year. So Nick invests $1,000 at a bank, offering 7.5% interest. Find the amount to the near, okay, so you have this. If it is compounded, we're just going to write the formula here for if it is compounded in the beginning, annually. So annually compound is just once a year. So that's the same formula that we used before. So that is, you know, A of t equals the principal, and then 1 plus the rate to the t. If you were to look at it in terms of this new formula, this number right here would be 1, and that would be 1. So I would divide this by 1 and multiply it by 1. So there is no change here. So a few things you just have to get used to. I'm going to do the first one and allow you to try to get through the rest of them. So semi-annually is twice a year. So if we're going to do the interest twice a year, what we do is we split that interest by 2, and then we square it. Okay? And then, you know, if you want to actually figure out the number here, what is that actual number? Well, it's 1,000 times 1.375 to the 2t power. So you can see you get less of a percentage. Your percentage rate is only 37 or 38%-ish, but then you square it, so it does it does have a slight advantage. It's not that big of an advantage, mind you, but it is slight advantage. So quarterly would be 4. Okay, and then you do the same thing. A of t equals 1,000. 1 plus 0.075, break that up 4 times, and then raise it to the 4th power. So when you do that, it winds up being 1,000, and then it's 1.1875 to the 4t. So finish these, see if you know what, you know, all those other words mean, and come back and check. Okay, so this is what this one looks like. Monthly would be 12, weekly is 52, and daily is 365. These are the numbers, but you can see the 12 is put here and there, 52 there and there. You can write that number if you want, but this is the formula that, of course, you need to have memorized. So here, if we pick apart the pieces, we look at this, I give you this formula, and I tell you this was compounded semi-annually, so that means twice a year. So I've given you the formula. You can kind of tell it's like that because of the 2 there. So is this growth or decay? Well, it's going down. This is 0.75. It's not 1. It's not higher than 1. It's less than 1. So this is a decay. What is the annual percentage rate? Well, the annual percentage rate is if this was raised to just the t power. So what we do to figure that out is we bring in the 2. So this isn't if this was compounded annually. This is how much, you know, what's the percentage I'm going to earn per year on this investment that I'm making. So we just do 0.95 and we square it. We bring that 2 inside. And so 0.95 squared is 0.9025 to the t power. And hopefully you know from yesterday how to find this. This is decay. So 1 minus r is 0.9025. So doing all the math and the math magic, r is 0.0975. Move it over 2 decimal places. How many people I just lose? Raise a hands. Raise a hands. But that's the idea. The basic idea of if we want to find the annual percentage rate, if we're given some other percentage rate, is we have to get it to the power of t, or t is years. So I just have to get rid of the 2. So I square it and I put it in here. And then I just do my math that I did yesterday. So here's another one for you. So this is, hopefully you can tell, this is greater than 1. So this is a growth problem. So you know when we do this formula, we're going to do 1 plus r equals whatever this number turns out to be. Well, right now it's being raised to the 12t power. So I'm going to bring that 12 inside, and I'm going to actually do 1.0056. I'm going to raise it to the 12th power. I'm going to bring it inside. Okay, and when I do that, I get 1.0693, whatever. Something like this, to the t power. So this is going to tell me my rate. So I plug that in here, and then simply just subtract 1. So when I do that, I get this, move it over 2 decimal places, and I get 6.93%. It's a little weird, but the way that it works, we're finding out how much I'm going to make, or how much is going to be increased every year if I do compound it monthly instead of yearly. It's interesting. Just gotta hang on to it and keep trying, and eventually it'll come to you. Okay. So so let's just actually use the formulas now, just to plug it in and see how it is. This up here is playing with the numbers a little. So we want to write a function that will model Molly's investment for her son. She earns 3% interest on $8,700 that she invested, and she's going to have it compounded weekly. Okay, so then when we plug this in, so actually I can use any letter here. It doesn't have to be A. So I'm going to use Molly, M of t, is equal to the principal, and then 1 plus the rate. So this is 3%. So remember, divide it by 100 or move it over. 0.03. Divide that by 52 and raise it to the 52t power. So now if I want to find out how much money that she'll get, if you want to figure out this number, here we go. Okay, so you can kind of see it's a really low percentage, but it's every week that she's getting this much money compounded into her. It's not a whole lot. So what's going to happen after 18 years? How much is she going to get? So we plug 18 in. You can put it in that one too, but it's just a little annoying to write that whole number out again. So we just plug that in, and after 18 years, to the nearest cent, we're going to figure it out. So what I have here, the number that shows up on my calculator, is this. So to round it to the nearest cent is the same as the nearest hundredth. Okay, 2 decimal places, so we're going to round it to here. So it's $14,926.94. So that's how much she should have in her account after 18 years. Not enough to pay for much college, but whatever. So in what year will Molly investment have doubled? So she invested $8,700 initially. So how long will it take for her investment to actually double? So, well, what's that number? If I multiply that by 2, it's $17,400. So when will she have that much money? Well, that's when we replace this part. So I'm going to use that formula, but I'm going to replace 1,700, whatever. You got me. I have issues saying numbers. 17,400. Her initial investment was 8,700. We invested in the 1 plus 0.03 over 52 to to the 52t power. And we need to solve for t. Okay, so if we divide by 8700, lo and behold, hopefully it's not too obvious to you, or it is sort of obvious to you, that you get 2, because that's how we figured out what the number was. And then it is 1 point. That number. Again, leave it in your calculator. Don't round anytime you're dealing with logs. Bring this guy. You run the risk of losing a lot of money, in this case, if you, excuse me, I always stop mid-sentence like that. If you leave a decimal out. Okay, so I'm solving for this t right here. So I'm going to divide by the log of this mess. And the log of the, I'm writing really large, so hopefully you're not running out of space on yours. So when I do divide by the log, I get a nice little number. I put it in my calculator, and then log of 2 divided by the log of the mess. And then I take that and divide that by 52. So we've done this enough. Okay, we've done this enough that hopefully you know how to do that, at least that little piece by now. And you find out that it's 23.11157 years. So he's gone through 23 years already. So in his 24th year, the money should have doubled. Okay, have a good day.